Last time we started talking about solutions. We're starting chapter 12, talking about mixtures. And in the last session, we know the difference between mixture and compound. Anyone can remind me what the difference between mixture and compound, guys? Do you remember what the difference between mixture and compound? Yes, Yasin?
لو مثلا mixture isn't chemically يعني bonded
Good.
إنما compound is chemically bonded.
Good. So we actually said compound once two or more substances, they are chemically bonded, resulting in formation of new chemical substances with completely different chemical properties. While mixture is just a physical combination in which substances just mix, blend together, but actually don't form any bond. So they still the same substances, but just mix it together. So here, like this, we said that mixture doesn't produce new substances or it doesn't change the chemical properties of the substances still as it is, okay? And easily could be separated. So guys, actually today we're going to continue talking about mixtures. Last time we studied the first type of mixture, which is solutions, and we know what is solution, what is made up of, and so on. So anyone can remind me what is solution? What is solution, guys? Anyone remember what is solution? Okay. So listen to me, guys. I'm gonna show a video for you, okay? And by watching the video, you're supposed to answer the following question, okay? So here, okay, guys. So by watching the video, you're supposed to answer the following questions, okay? So the first, what is solution? Okay, that's actually we explained that last time, but just kind of remember what the different types of what are the types of mixtures, what are the types of heterogeneous mixtures, and then what the difference between colloid and suspension, and finally, what is the Tyndall effect? Okay, so these here that's questions. So watch the video carefully, okay, and start to write down your notes because we're just gonna receive the answers after the video. Okay, so let's start here, guys. Okay, guys, we're getting to the part we watched. We now are able to answer what is solution and what are the types of mixtures. So who could answer the second question first? What are types of mixtures? So we have two types of mixtures, which are what kind?
Homogeneous and heterogeneous.
Okay, higher. Okay, so homogeneous and heterogeneous. Okay, so who can tell me what the difference between homogeneous and heterogeneous mixture? Yes, Jenna. What difference between homogeneous mixture and heterogeneous mixture? Okay, Mariam.
The homogeneous mixture maintains the same qualities throughout the mixing,
Yeah,
but
that
the
means
heterogeneous doesn't.
yeah, good. The heterogeneous does not. Okay, so simply that we could say homogeneous mixture, that the mixture that you cannot distinguish its components. It's look the same, have the same outlook, okay, or they have the same outfit, okay. It's look just one thing, okay. Could not know its components. For example, like once you look to the milk, okay. Sorry, once you look at salt solution. So that is a homogeneous mixture. While we find here, okay, heterogeneous mixture, the mixtures that you could distinguish its component, you find that they have different components. Okay, once you look at it, okay, for example, like when you put sand in water, okay, you could easily distinguish between sand and water. So like this, we have homogeneous mixture and heterogeneous mixture. So what is solution? Who can tell me? What is solution, guys? Yes, Abdurrahman Walid. Walid.
Mr.
Yep.
Solution is when liquid or gas or solid dissolve in liquid.
So actually, it's not a must to dissolve in the liquid because actually we have more classification. So simply, you can say that solution, it's a kind. Is it homogeneous or heterogeneous mixture first?
Homogeneous.
Homogeneous. So solution is the alternative name for the homogeneous mixtures. Okay. In a solution, it's a substance that's gonna dissolve in another substance, whatever the state of the substance it is. Okay. So here, like this, we find that solution. It is a homogeneous mixture in which a substance is gonna dissolve in another substance. So the substance which we dissolve, we call it
Uh,
good
solute.
solute. Yes, solute. Okay. So solute.
Solute.
So solute, that the substance which dissolve, like, okay, for example, the
Like salt.
sugar, salt, blah blah. Okay, this is solute. While, okay, the substance in which the solute dissolves in, we call it
Solvent.
solvent. So as we said last session, okay, solute plus solvent, they are gonna produce solution. Regarding to the state of solute and solute and solvent, we could classify the solution into many categories. Okay, so we have solid. Okay, we have gas solution. Okay, as we said last time, like once oxygen dissolves in nitrogen, we have gas liquid like carbon dioxide dissolved in water. We have liquid like alcohol dissolves in water. Liquid solid like mercury and silver. Okay, and 10. So we have solid in liquid like sugar in water, and solid in solid that in different alloys, okay, as we explained in the last session. So that's here, on this part, we're still covering, or we just recap what we studied in the last part, okay, on the lesson. Today, we are going to need to answer this new 3 questions, okay? So here, we're going to continue watching the video, guys, okay, and try to answer the 3 questions. So just write them down. What are the types of heterogeneous mixtures? What's the difference between colloid and suspension, and what is the Tyndall effect? Okay, are you ready, guys?
Yes.
Okay, so let's watch here. Guys, so let's back to our questions and try to answer it. So who can tell me what are the types of heterogeneous mixtures? Okay, yes, yes, Tawakkul.
Suspension colloid.
So suspension and colloid. So here we have heterogeneous mixture like suspension and colloid. So what the difference between colloid and suspension, guys? Who can tell me? Yes, Tadrus? That's who's
Colloid, the particles are larger.
yes, in colloid no, in colloid particles are
Smaller.
smaller than suspension. Okay.
Mm.
Actually, the particles in suspension, they are somehow are big enough to settle down, just to drop at the bottom of the beaker. Okay. So like the sand particles, okay, their size could be more than 10 power of -5 centimeters. So like this, it's a big enough not be to be completely carried by the water particles. So they are gonna settle down, and that's because of, and some of these particles will keep suspended between the water molecules. So that's why we call it suspension. While colloid, okay, it has smaller particles. So what happens to these, to the colloid, okay, the particles keep, okay, eventually or actually distributed, okay. So like this, we find that they somehow are distributed within or they don't dissolve but keep distributed equally. That's why it's look like a homogeneous mixture. That's once you look at milk, you never imagine that is a heterogeneous mixture, okay, because it's look like a homogeneous, it's have the same outlook, but actually under microscope you find that the particles are equally suspended, okay, and sorry, are equally distributed in the beaker. Okay, so here like this, we know the main difference between colloid and suspension is the size of the particles. Okay, we know example for suspension like sand in water, example for colloid like milk. So let's pass to the last question. What is the Tyndall effect? Who can tell me what is the Tyndall effect regarding to what you watch it in the video, guys? Yes, Knuz?
I think that the light doesn't pass through colloid.
Doesn't pass completely or partially?
Partially.
Partially. Okay, so actually Tyndall effect, okay, that's we find that because the particles in colloid somehow they are equally distributed. So once the light pass through it, okay, some of the light will be scattered, okay, and the little amount of light will pass out from the other side. So in that case here, we call this the Tyndall effect. While if we just watch the effect of the light on suspension, we find that the water, okay, the light will be completely, okay, scattered. So in that case, actually, they were gonna find the light cannot pass, okay. But in solution, we find because in solution the particles are too small, so a little part of light is scattered and most light could pass. So here the effect of, so once we ask what is the Tyndall effect, we see that the effect of light on colloids, okay, in which the light or some of the light will be scattered because of the particles of colloid, which is equally distributed, okay, within the container, okay, and so here like this, guys, let's try back to or just pass to our textbook to find that part. So here, this here that represents a kind, or that's what actually give you some examples of colloids, which is already we could find in our daily life, or we use it in our daily life. So here we could find, for example, the gel, different kind of gel. Okay, so like that's a solid network with just found or extending throughout a liquid, like the gelatin, which we use it, okay, in different forms. Liquid emulsion, that's a liquid, okay, that's completely or dispersed, that means just distributed in a liquid like milk and mayonnaise, okay. So like that mean we could say that milk actually it's a colloid. What kind or what class of colloid? It's liquid emulsion, okay. So here we have the foam, okay. So foam, that's it's a gas which is actually distributed in a liquid like the shaving cream, whipped cream, okay. So that's class of colloid. Then we have the solid aerosols, okay. Solid aerosols, like solid that is distributed, okay, in a gas like smoke, okay. Airborne particles, matter, auto exist. That means that the different things that which come of the existers of cars and different things, because it have some solid particles that already distributed within a gas. Liquid aerosol, like liquid that distributed in gas, okay, like the fog, mist, clouds, and aerosol spray, like different spray that we use in our life, okay. So here, solid emulsion, that means a liquid, okay, liquid distributed in solid, okay. So that's here, okay, what is it's like cheese and okay. So like here, guys, we could find that we have different classes of colloids. So depend on the state of the substance, okay. That means what the state of substance that disturb it in which state, okay. So here are the different classes of colloids. So just we're gonna just here find if we need to make a little comparison between solution, colloids, and suspension. So as you can see, all of them are heterogeneous mixtures because we said, okay, so sorry, colloids and suspension are heterogeneous mixtures because particle does not dissolve, while here solution is homogeneous because we said that the solute will completely dissolve in solvent, so overall it will have the same out form. So here like this, we find the particle size is just about 0.01 to up to 1 nanometer, okay, which is very too small, okay. So that means it could be atoms, ions, or even smaller molecules, okay. So here like this, we could find here the solution do not separate on a standing one. That means you get solution of salty water and leave it even for years. It will not separate. The salt will keep dissolving in water. Cannot separate by filtration. That means if you start to use a filter, do you know filtering paper or filtration paper, guys? When we use filtration paper, okay, just to filter, it's something, a paper that has small tiny holes like refinery that we use to separate solids from liquids. So actually, the size of the holes of filtration paper is bigger than the size of the particles of solution. So actually, it is not able to separate them, and it doesn't, or the solution doesn't scatter light. That means here the light could easily pass through solutions. While in colloids, we find the big difference here that the size of the particle somehow is bigger. It's 1,000 times bigger than, okay, the solution size. So we are gonna find here the particles will be dispersed. That means equally distributed, okay. And here they don't separate also. That means if you get a cup of milk and you leave it for, okay, hours, days, even years, okay, it's still the same components and the same distribution. They will not separate, okay. And we find here Also, it cannot be separated by the filtration because the size of particles is still smaller than the diameter of the holes of the filtration paper. Okay, and it could scatter light, which we know as Tyndall effect, as we said. Here, suspension, the last type here, it's a heterogeneous mixture in which it has the largest size of particles. So these particles are too big to keep, okay, distributed within that liquid or within the other substance. So it will settle down and so few will be suspended. So actually here it could be separated by time, that once you just leave it, okay, you're gonna, or that's good. Once you let this beaker of salt, sand and water, finally you're gonna find most of sand settle down at the bottom of the beaker, okay, while few still suspended. And it could be separated by filtration because the size of particles is big enough to be, okay, captured by the holes of the filtration paper, so the liquid will pass in while the particle of the sand will be over the filtration paper. And it may scatter light, or it just scatter, okay, most of the light, okay. That means it's not transparent, okay. So here like this, we find that the difference between solution, colloid, and suspension. So any hard point, okay, regarding to the properties of any one of these guys?
No, Mr.
Is there anything is not clear?
No.
Okay, so here, guys, we just pause here to that's here. We said that's this is the little part here we need to show to you. Okay, regarding to the Tyndall effect. Okay, we find that the Tyndall effect just mentioned, or that's depend usually regarding to the colloid, because colloid, they are the kind of mixture which scatter the light, okay, and this scattering of light appears clearly. So here like this, we have something called the Brownian motion. Okay, so what is Brownian motion? So we said that this motion is due to collisions of rapidly moving molecules. Okay, that means the part, this kind of scattering the light, or why special colloid could scatter the light, because particles are somehow, they are equally distributed, okay, within the other substance. So, and these particles in continuous motion, so somehow they fill most of the space, so the light cannot find an empty space that just to pass easily. It's always gonna hit with a molecule which cause, okay, the light to be scattered, okay. So this motion of the colloid particle called is the Brownian motion, okay. Is it clear, guys?
Yes, Mr.
Any hard question at that point, guys?
No.
Okay, so the last part we're going to talk about here, guys, that is the electrolyte and non-electrolytes. So what is electrolyte and non-electrolyte? Actually, electrolytes, we say that they are the solutions which could conduct electricity, while non-electrolytes, they are the solutions that cannot conduct electricity. What does it mean? It means that some solids, for example, when you dissolve some salt in water, okay, and then you start to make a simple electric circuit. That means you just put, okay, an electric, that, let's see here, guys, that mean, look at me, if we get just this speaker contains salt solution, that means already we have salt in water, so that is salty. And then we just make a kind of electric circuit in which we have a wire, battery, and then we have this little lamp to detect if current is gonna pass or not, and then put it here, okay? So the two wires actually are not connected to each other, just dropped in the salt solution. So we're gonna find that the light is gonna, okay, or the bulb is gonna light, okay? So which means that the electrons or the electric current could pass, okay, within the salt solution. That means the salty solution or salt considered as electrolyte. It's a substance that dissolves, or once it dissolves, is able to conduct electricity. While in the other hand, if we made the same experiment, okay, but instead of using the salt solution, we're gonna use a sugar solution, that we're gonna just make sugar dissolve in water, okay. So once we make a sugary solution, just put sugar here, we're gonna find that the light will not be able, or the bulb will not light, okay. So why? Because actually sugar, once it dissolves, it doesn't allow electrons, or doesn't allow current to pass through. So what the difference between salt and sugar? If both of them, they could dissolve in water, so why this one could or able to conduct electricity while sugar cannot? To answer this question, watch the following video, guys, then tell me the reason. Okay? Okay, guys?
Okay.
So let's, okay, watch the video here. Regarding to this part, guys, so what is a strong electrolyte, or why electrolytes is able to conduct electricity? Guys, who can tell me why electrolytes be able to conduct electricity? We're going to watch a video. For example, here, once you observe, yes, Gizi?
Because electrolyte is a salt or ionizable molecule. Yeah?
Yes, I know. Good. So you get a good word. Ionizable molecule. That means it's a or ionizable okay,
Can be
substance.
ionized.
Yes. So can be ionized. That means it break down, or once it dissolves, it break down into positive ions and negative ions. Okay. So here, like this, guys, like sodium chloride, for example, or the salts, once it dissolve, it break into sodium ions and chlorine ions, cation and anion. So these negative ions, once we just make this experiment, we just put the two roots in this. So the positive, okay, the positive ion will pass to the negative pole of the circuit, while the chlorine or the negative ion will pass to the positive pole of the circuit. So they move to the opposite, okay, poles. In that case, they are gonna close the circuit, or they are just allow the current to pass. So it means here the ions allow the electricity to pass within the solution. So like this, they could conduct electricity. So here, this like, so most ionic compounds, or all ionic compounds, they consider to be strong electrolytes because they break down into ions. Simply here, some covalent, okay, compounds like strong acids, only strong acids, okay, like hydrochloric acid, sulfuric acid, phosphoric acid, okay. These acids, they also consider to be good electrolytes or strong electrolytes. Why? Because they break down completely into hydrogen ion, which is positive, and okay, the chlorine ion in case of hydrochloric acid, or sulfate ion in case of sulfuric acid, and so on. So also they could conduct electricity. So like this, the electrolyte is the substance that could break down producing ions. Okay, once it produces ions, it's gonna allow current to pass. While in the other hand,
carry
let's
the
watch.
current.
Okay, you can tell me why non-electrolyte solids, why sugar does not able to okay, allow current to pass? Yes, Yassine?
Because water does not separate them into ions. It's
Yep.
it remains
It, good. It dissolves. That means breaks down, but actually it doesn't break down into ions. It breaks down into smaller molecules or smaller particles, okay? But it's not a charged particles. That means it's not ions. So in that case, it will not be able to conduct electricity. You get this, guys? Okay, is it clear?
Yes, Mr.
So now, like this, we could differentiate between electrolyte and non-electrolyte substance.
Yes.
Okay, so like this, guys, we already finished our section. Okay, so that's section 1 of chapter 12. Please study very well from textbook, and next time, inshallah, we're gonna discuss it. Answer your section review, page 406. Okay, and then we're gonna discuss it. Okay, the difficult point next time, inshallah. Thank you, guys, and goodbye.